Lesson 3, 2.3, Adding and Subtracting Radical Expressions. Like terms or like radicals in a sum or difference of radicals, so when there's adding or subtracting, have the same radicand and the same index. So, for example, the like term to root 3 is 4 root 3. There is no like term to root 7. Even though they have the same index, then the radicand underneath is not the same. So if we would add them together, root 3 plus 4 root 3 plus 2 root 7 is 1 plus 4, so 5 root 3 plus 2 root 7. If I were to just use, say, variables, I would say x plus 2y plus 4x. Okay, so our root 3 is like our x, and our root 7 is like our y. I would get the final answer of 1x plus 4x equals 5x plus 2y. Just like here, we have 5 root 3 plus 2 root 7. So whenever you see square roots or cubed roots or whatever, think of those as variables. So this one right here, for example 1, I'm going to use a lot of highlighters because I find them helpful. So this is a like term to this. So I have 9 of some quantity and I subtract 5 of that same quantity. So what I'm going to do is 9 minus 5 is 4. And my variable, or it's not really a variable, but my quantity really is root 5. Done. Now, if we look at this one right here, let's not pawn this off too quickly as not solvable, even though sometimes we would like to run away from a question that looks like this. First things first is we always want to simplify the radical to see if there are any like terms. So for example here, I'm looking for the largest cubed root factor in each of them. So what I'm going to do is I'm going to say, okay, the cubed root, now remember this is not a coefficient, this signifies the cubed root. So the cubed root of 24 is the same thing as 8 times 3, because 8 is a perfect cubed factor, minus the cubed root of 64 times 3. 64 is 4 cubed, minus the cubed root of 125 times 3, which is 5 cubed. So here's the thing, we're noticing, hey, 3, 3, 3, that's what's going to be left over. So if I wanted to take this really slow, I would say, okay, the cubed root of 8 times the cubed root of 3, remember this is an index, not a coefficient, minus the cubed root of 64 times the cubed root of 3, minus the cubed root of 125 times the cubed root of 3. So the cubed root of 8 is going to be 2. And there's no simplification that I can do here, even though it feels like it could be 1. I know if somebody looks at that, it looks a little funny, because what's the cubed root of 3? But if you think about it, there's no integer, or there's no whole number that can be multiplied by itself 3 times to get 3. Minus 4 times the cubed root of 3 minus 5 times the cubed root of 3. So I have 2 of something, and I subtract 4, so I'm at negative 2, and then I subtract 5 of that same quantity, so I'm at negative 7 times the cubed root of 3. Done! That's great. I'm going to put a box around it. Now this one right here, it doesn't seem like there are any like terms again, but first things first, let's simplify them. So we're noticing that there is no official index here, so that means that the implied one is 2, they're square roots. So we're going to look for the biggest square root factors. So 63 is the same thing as 9 times 7 plus 40 is the same thing as 4 times 10, because 4 is a perfect square factor, minus 90, which is 9 times 10, minus 28, which is going to be 4 times 7. Not 4.7, that looks silly. 4 times 7. Now we're noticing a trend here, right? We're seeing that there's the root 7, root 10, root 10, root 7. So that's a good sign. We're going to have two different like terms here. So I'm going to skip the step where I separate them out. The square root of 9 is 3. And what I'm left with under the radical is root 7. Plus the square root of 4 is 2 times root 10 minus 3 times root 10 minus the square root of 4 is 2 times root 7. What I love about this question is that it really highlights that the radical is what makes it a like term. See, I see there's negative or subtracting 2 root 7, and I'm seeing 2 root 10, but the 2 root 10 and 2 root 7 are not like terms. The 2 root 7 is actually matched with the 3 root 7 because that's the quantity that's similar. Then I'm going to highlight the like terms here. 2 root 10 minus 3 root 10. So 3 root 7 minus 2 root 7 is simply going to be 1 root 7, so I can just write root 7. 2 root 10 minus 3 root 10, that's negative 1 root 10, so I just write root 10. And we're done. It feels like we can go further than this, but we truly cannot.